Good morning, friends. Today we discuss about the topic that is the fundamental of organic reaction mechanism. Fundamental of organic reaction mechanism. In that we discuss about the inductive effect. What is meant by the inductive effect? Then here in this case, the inductive effect can be defined as the effect that arises due to the tendency of an atom or group of atom to attract or repel the electrons in covalent bond. To attract or repel the electrons in the covalent bond. A covalent bond is found between the two atoms, that is by sharing of electrons is takes place in the covalent bond. In case of covalent bond between the two like or the similar atoms, hydrogen, hydrogen, hydrogen single bond hydrogen, chloride, chlorine single bond chlorine, then bromine single bond bromine. Like this, the similar atoms, or if the shared electrons are situated exactly at the center of two nuclei and they are shared equally. It means that two atoms are similar atoms, that is the hydrogen, hydrogen, hydrogen single bond hydrogen. That is, it means that the similar atomic number, similar nucleus, and they exactly center of two nuclei and they are shared equally. Such as the that is the single one hydrogen atom, it shares one electrons. Another hydrogen atoms attached with the in the H2 molecule, they shared one electron. It means that one electron from the first hydrogen atom and one electron from the another second hydrogen atoms. That is, the sharing of electron is takes place in the covalent bond. If the covalent bond is found between the unlike atom, that is the HCl, for example HCl. In the HCl, HBr, HI, these are the different atoms. These are the different atoms. So there is the hydrogen atoms, atomic number is 1, while the chloride atomic number is different, that is the 17 hydrogen atom atomic number. Here, if the covalent bond is found between the two unlike atoms, the electron pair forming the bond is never shared equally between the atoms. If the unlike atoms are attached, then what happens? It tends to attracted electron more electronegative atoms of the two. It means that thus thus in an alkyl chloride, the electron density is greater nearer to the chloride than that of the carbon atoms, as the chlorine is more electronegative than that of the carbon atoms. So for an example of alkyl chloride, that is for example of HCl, HBr, HI, it means that is the chloride atom having the more electronegativity, that is the electrons are attracted towards itself and than that of the carbon atoms, more than that of the hydrogen atoms. It attracts the electron towards itself and formation of the partial negative charge on the halogen atoms, that is the chloride atom, bromide atom, or the iodide atoms. And the carbon atom forms the partial positive charges because the carbon atom having the less electronegative than that of the chloride atom. Thus, for example, the 2-chloropropane. What happens in case of the 2-chloropropane? That is, the chloride acquires the partial negative charge and the second carbon atom, this carbon atom forms the partial positive charge. Let's we consider the carbon chain in the molecule of N-propyl chloride. N-propyl, that is one of the first carbon atom attached with the chloride atoms. Then that is the carbon first, second, and then third. first chloride atom, that is the chloride atom is attached, and the chloride atom, it attracts the electron towards itself more from the first carbon atom than that of the second, than that of the third. In the first carbon atom, formation of del positive, first del positive, first carbon atom, and then second carbon atom, they forms the two del positive charges, and in the third carbon atom, three del positive charges on the three third carbon atoms. Like this, the like this is the and the chloride atom forms the partial negative charge. Thus, the chloride atom being highly electronegative, and it withdraw the electron from the C1Cl, that is the first carbon atoms and chloride atoms bond, and C1 as a result becomes slightly electron deficient and acquires the positive charge in terms of withdraw electron from the C1 and C1 single bond C2. That is the bonding between the first carbon atom and the second carbon atom. As a result of that, is the carbon atom second acquires a little positive charge through a less than that of C1. This effect is known as this effect is known as the inductive effect. The inductive effect is transmitted to the C3, it means that the carbon atom 3, and to less extent. This shown by the arrows of pointing to the direction of electron displacement and the carbon chain in N-propyl chloride. N-propyl chloride. That is the more positive charges on the carbon atom third. The inductive effect is decreases as the distance from the electronegative atom is increases. Inductive effect is decreases from while we go from C1, C2, C3, then the inductive effect is decreases as the electronegative atom is element is increases. It is also almost negligible after 2 or 3 carbon atom, that is the carbon atom second and third carbon atom, the inductive effect is very negligible. This is a permanent effect, and when the electron displacement is away from the carbon atom forming carbon Cl, that is the carbon single bond Cl, and this as in the above, that is above example N-propyl chloride, the inductive effect is said to be, that is the first, that is the negative inductive effect. The electron refilling atoms which supply the electron to such carbon atoms is said to be positive inductive effect, that is plus I effect, that is the positive inductive effect. Minus I effect, when it will happen, minus I effect, when the electron withdrawing groups are attached to, that is the NO2, chloride, bromide, sulfate and hydroxides. Then the plus I effect is occurred on, that is electron withdrawing group is occurred. Minus I effect, electron donating, plus I effect, electron withdrawing, that is the methane, isopropyl, oxygen, sulfur. These are the electron donating and the electron withdrawing group. This effect, that is the electron displacement is away from the carbon atom, that is this carbon single bond chloride bond is an example, that is the N-propyl chloride, N-butyl chloride or N-pentyl chloride. The inductive effect, this effect is known as that is the minus I effect, that is minus I effect. And then the electron repelling the atoms we supply the electron to such carbon atom is said to be the plus I effect. That is the positive inductive effect. Positive inductive effect. Minus I effect, for example, the NO2, fluoride, chloride, bromide, SO3 and oxide, hydroxides etc. Plus I effect, that is the methyl, isopropyl, and then oxygen, sulfur etc. This is the inductive effect. Inductive effect.